Hey everyone, this is FixReef, and today we have another Apex EB832 up for repair. This one came in with an issue that it smokes from the inside. Smoking from the inside is usually actually a great indicator because it immediately tells you where the problem is, but in some cases it can get a little bit more complicated to fix, especially if the damage is significant. I already opened up this EB832 to save time. And the first thing that I've noticed, and that's the only thing that I've noticed so far, is that there is some water damage. Let me try to zoom in so you can see. But there is clearly water damage on the ports board over here. So all of the Aquabus ports, one link, auxiliary 24-volt ports, they're all damaged, and the components around here are damaged. So what we're going to do, well, let's finish the visual inspection first, and then we're going to likely take this board off and see what kind of damage is on it and whether or not we can fix it. So let's look at the back of this. I am not seeing visually a whole lot of damage. There is clearly a little bit of corrosion on a couple of components, but fairly minor. A little bit on the 24-volt power supply, but very minor. This is just vapors that ended up settling on here, which is likely very minor and not causing any problems. The issue is clearly with the connector board on here. Okay, let's first figure out how we're going to remove it. In most cases of this type, I prefer to remove this board with the help of low melt solder, primarily because there are so many connectors, so many pins on this little board. There are about 1.5 dozen pins on this, about exactly 14 pins here holding it to the main board, and there is no way I can have them all desoldered at the same time to get it off, to assess the problem. So we're going to use some low melt solder and try to get it off. I'm going to get under the microscope for this just to make sure that I do not mess it up, and you're invited to follow along. Okay, so these are the pins that we get to work with. Let's apply a little bit of low melt solder to each and the individual pin here. Make sure that we can melt it. Actually, what I'm going to do first to help with the process is I'm going to suck in all of the solder from the pins. They're pretty big. So to further lower the melting temperature, let's get rid of the unleaded solder as much as possible. Nice wick sucks in under proper heat all of this solder right away. Nice and clean. Alright, now I'm gonna apply some low melt solder to each and every individual pin. And make sure that it penetrates each spot really good. The low melt solder is so soft that even now that this board is a little bit, heated, even from the heat of the board, it starts melting right away. So this is why using it for the purposes of removing components that are otherwise hard to remove, specifically connectors that you actually want to save. It's perfect. Okay, now let's see if we can get it off. And the connector is off. Okay, now that the connector is off, take a closer look at the main board just to make sure that there is not actually a significant corrosion there, and it doesn't look like it. This looks perfectly clean. So I don't think we have to worry about the main board at this point. So instead, let's focus our attention on the connector board. This way you can see a little bit better all of the corrosion that occurred here. So I think it doesn't look too bad. Smoke probably came off of one of the shorted maybe resistor, maybe capacitor, maybe something else on here. Let's actually look under the microscope. Let's see if we can find where the burned smoke was coming from. Okay, so this is the back of the board. There is definitely some corrosion all over the place, but looks like a surface corrosion, so it may not be as bad. Yeah, this is definitely not as bad. So here's one component that clearly got heat with a lot of water. There is another one, and this is where the short is. You can see that this has definitely has burn damage. Nowhere else does it have that damage. So it's right here. So what exactly is this? This is, hopefully you can see, but this looks like a one-link port that is having this short. So this is what I'm proposing. This needs to be ultrasonically cleaned anyway. So why don't we put it under the cleaner, have it all cleaned up, and then test for shorts. So this is where the smoke came from. There is definitely a burn mark over here. There was a short. So there are 4 pins here. 4 pins indicate that this is going to be a one link. 2 pins for data, 2 pins for power. Obviously, smoking means likely power damage. This is this middle port. Let me see if we have any kind of short on this port right now. All right, okay. All right, let's see. Yes, there is definitely a short between these 2 pins. And these 2 pins is data. There is no short on this. There is no short on this, so that's great, which means that the diode is probably okay, but there is a short between these 2 pins. So I propose that we get this board through the ultrasonic cleaner, have it nice and clean, then get it out of the cleaner and look at what's going on with this port. It will either have to be replaced or maybe even repaired if we're lucky. Let's find out. Okay, so this board is back from the ultrasonic. Let's take a look at what we have now. I must say that the ultrasonic did an excellent job. This has not gone through any kind of post-processing yet, and there is really not much to do. Most of the corrosion is gone. The board looks much better, but mostly what's awesome about ultrasonic cleaning is that all of the corrosion off of the ports is gone. Like there is absolutely no corrosion left on here. So that's great. Now, what we need to do is we need to pay attention to the area where we had a short and check to see if the short is still there. My guess is that the short is probably still going to be there because, I mean, ultrasonic gets rid of the corrosion, but it does not get rid of uh, traces that have shorted. So let's take a look. All right. And there is still a short on these 2 pins. Okay, well, that's expected. That's not a big deal. Let's take a look under the microscope around this to see what kind of traces we have, and also to see if we need to replace or remove this connector. Okay, so this is where our short is. Kind of dark and hard to see, but there is definitely, now that all of the salt's gone, there is definitely a side of burned components. However, you can see that there are now traces to these 2 pins, not from one pin anyhow. There is this other pin that definitely has traces to it, but not this pin. So these 2 have a short and they shouldn't. Let's look on the other side. There is definitely some type of hot mess going on here. Alright, I tell you what. Let's remove the connector and see what we get under this connector. Because this connector is plastic, I'm going to once again use low melt solder to remove it, as I don't want to damage the connector in case it can be salvaged. So first, we'll remove the original unleaded solder. Looks like there is not much left. Corrosion take care of the rest. So now I'm gonna apply a little bit of low melt. That's better. Much better. All right. Now I'll use my holder to attempt to remove the connector. And it's off. The connector is off, but one of its pins is still on there. And now that pin is off. Okay, with the connector totally off, let's examine to see if we still have a short on those 2 pins. There is still a short. So this indicates that the problem is with the board itself shorting and not the connector, which is reasonable. I'm going to get under the microscope and we'll clean up and repair the board. One side first. That's probably the best we can get out of it for now. Now onto the other side. It does look messy, so I'm not surprised that it's given us a short. So this trace is lifting. And this trace is supposed to get us to here. So this will definitely have to be repaired. Let's see what it is. Oh, okay, that looks like solder to me. So as the higher temperature due to the short was applied to this area, it melted the solder that was on the pin out and it ended up on the trace. And when it did, it went all over the place, shorting everything in its path. So the big question right now is, after this short, are we still going to have a good Aquabus connectivity here or not? The goal is to separate this trace from this uh, hole over here, because currently those two are lightly shorted. I doubt that this board is multi-layer, so there is probably everything on this layer and the other layer, so hopefully nothing in between is causing the short. So if we were to attempt to remove the short here, we might be in a good position to repair this. Okay, once again, test if the short is gone. I'm not seeing the short anymore, so there is definitely some connectivity, but yeah, no, there's not supposed to be any kind of resistance value on it, and there is still some. So we got most of it off, but not exactly everything. So there is still some. Let's keep on scraping. Let's see if it's meltable, as it might have. Yeah, it probably welded itself. Let's remove all we can. I need to clean up the holes anyway. Let's check resistance again. And it's in mega ohms. There is no short. The short is entirely gone. Okay, excellent. Okay, now that the short is gone, final cleanup on the side. Let's flip it over. A bit more cleanup over on this side. And let's try to install the connector. So before we reinstall the connector, I want to clean up the pads so that to remove the oxidation that's on there. To remove this oxidation, just a little bit of flux on all four holes and clean it up real well. With a really hot iron and wick until it's shiny. Once those pads are shiny, we know that they're gonna take solder. This looks really nice. Now I will reinstall the connector. Connector goes in real good and solder it back in place. Just because of the prior oxidation, I'm going to add a little bit more flux, just to add it a little bit more strength when soldering. Beautiful, like new. Went in just like new. Now this deserves one last cleanup. And one last test for any shorts. And it's still in mega ohms. Very cool. Now that the module's been repaired, it's time to install it into the main board. But before we can do so, we have to clean up those 1.5 dozen mounting holes that we have, primarily so that we can have room to install the new one, but also to absolutely remove all of that low melt solder, as it will not allow for proper strength, and you need strength for this board. So let's go back under the microscope and clean it up. All right, beautiful. There's only one stubborn hole remaining. Let's see if we can get it. Got it. Looks like new. Now install the board back in. Beautiful. I will have to secure a couple of pins first so that it stays intact. And that's going to keep it in. Now finish off all of the pins. Okay, now all of them are in place. More cleaning. And this should have fixed the connector board. Now let's see if this EB832 is going to work again. I see healthy clicks. I see the 12 volt power supply having it on, but the 24 volt power supply LED anyway is dark. It's still clicking through though, so I'm not quite sure what's going on. I'm going to flip it over and I'm going to measure if the 24 volt power supply actually produces 24 volts. Because if it doesn't, we have more problems, but I hear all kinds of clicks everywhere, which indicates that we should be somewhere where we need to be. Okay, so this is my 24 volt output. And it does produce 24 volts, although the LED is off. Okay, well, I don't have to worry about the LED on this thing, as long as it works. Okay, so I will do some more testing on this EB832, but it looks like it's working just fine so far. I need to make sure that there is still connectivity to the head unit, because my concern is that when there is a short on the Aquabus port or a one-link port, it may propagate over to the data pins, which would burn out the transceiver. So I'll have to check for that. I also am going to suggest to the customer to upgrade these old 12 volt power supply capacitors. And if that's all right, I'm going to do that. And if everything checks out, this EB832 is going to be officially fixed. But this concludes this repair video. If you enjoyed this content, please like and subscribe, and I will see you next time.